Hello everyone. In this question, it is asked that if the ratio of the roots of the equations ax square plus 2bx plus c equal to 0 and px square plus 2qx plus r equal to 0 are equal, then find the value of b square upon q square times p upon a times r upon c. Okay, where all these a, b, c, all these coefficients a, b, c, p, q, r are all real numbers. Okay. So we are given two equations ax square plus 2bx plus c equal to 0. This is the first equation. The other equation is px square plus 2qx plus r equal to 0. And we are given the ratio of the roots of the equations are equal. Okay. So if I take the roots of the first equation to be, let's say, m alpha and n alpha, and the roots of the second equation to be m beta and n beta, okay, where m and are integers, say, then the ratio of roots are now m alpha by n alpha. This is for the first equation. Okay, this is equal to m upon n, right? And for the other equation it is m beta upon n beta. So this is again equal to m upon n, right? So if I take this pair of roots, the ratio of the roots of both equations are equal, right? These are equal to the ratio of the roots are equal to m by n. Okay, so now for the first equation, the roots are m alpha and n alpha, right? And the equation is ax square plus 2bx plus c equal to 0. Okay, so from there, let us try to find the sum of roots for the first equation and product of roots. So this is given by m alpha plus n alpha will be the negative of coefficient of x, that is negative of minus 2b upon a. Okay, so from here if I take alpha common, I can get m plus n times alpha is minus 2b upon a. Okay, so no issue here. Now if I find the value of alpha, alpha will be minus 2b upon a times 1 upon m plus n. Okay, this is the value of alpha. Okay, now let us find the product of roots m alpha times n alpha. This is given by the constant term upon coefficient of x square, that is c upon a. So this will become mn times alpha square is equal to c upon a. Okay, so this is the first equation. Similarly, from the second equation, I can get m beta plus n beta will be equal to minus 2q upon r. Sorry, upon p. Sorry, minus 2q upon p. Okay, so from here I can take m plus n common again times beta, and this will be equal to minus 2q upon p. So if I take beta, beta will be equal to minus 2q upon p times 1 upon m plus n. Similarly, the product of roots for the second equation will be m beta times n beta equal to constant term which is r upon p, which means the product mn and beta times beta is beta square will be equal to r upon p. Okay, so we have to find this value, right? Some this b square upon q square, p upon a, r upon c. Okay, so let us find the condition what can be derived from this ratio of roots being equal. Okay, so here from this mn alpha square equal to c upon a, here the value of mn becomes c upon a times 1 upon alpha square, right? Okay, so this is one equation. Let me give it 1, and here mn will again be equal to r upon p times 1 upon beta square. Okay, now we are given this value of alpha. So let me find the value of 1 upon alpha square from this equation. Okay, so if I give this equation 3 and if I give this equation as 4, okay, so from 3 let me find out from 3 the value of alpha is this, right? So 1 upon alpha will be the reciprocal, right? So 1 upon alpha will be the reciprocal, which is minus a times m plus n upon twice b, right? I've just reciprocated. I've just reciprocal this both sides of equation 3. Okay, here in the denominator it was a times m plus n, so this has come in the numerator, and this minus 2b, this minus sign is up here and 2b is in the denominator. Okay, now in equation 1, 1 upon alpha square is there. Okay, so I have to find 1 upon alpha. I have to find 1 upon alpha square from this equation. Okay, so this implies if I square both sides, I can get 1 upon alpha square, which means I have to square this entire thing. So this will give me a square times m plus n, and on squaring this 2b, I'll get 4b square. Okay, similarly from 4, I can get 1 upon beta, which is this minus p times m plus n upon twice q, right? Here twice q is in the numerator, so on reciprocaling it, it will come in the denominator. So again, I need to find 1 upon beta square, right? Because in equation number, this is 1. Oh, let me give this as equation 2. Okay. In equation 2, we have 1 upon beta square, right? So I have to square both sides again. So this will give me 1 upon beta square will be equal to p square times m plus n upon 2q whole square will give me 4q square. Okay. So now I have 1 upon alpha square and 1 upon beta square, right? So let me write both of these combined as equation 5. Okay. So now equation 1 and equation 2, both of these equations in the left hand side is equal, right? Both of this equation 2 and equation 1 both have mn in the left hand side. So I can equate them, right? So I can equate 1 and 2, equating 1 and 2, it's c upon a times, this is 1 upon alpha square, right? So 1 upon alpha square is nothing but this. So I can use this here, times a square m plus n upon 4b square will be equal to equation 2 r upon p times 1 upon beta square, right? 1 upon beta square is nothing but p square times m plus n upon 4q square. Okay, so from here we can see that this a and this a square will cancel out, and here again this p square and p will cancel out. Okay, and this 4 in the denominator of both sides will cancel out. So we are left with this ac times m plus n upon b square is equal to, here only a single p is left, it was p square before, so pr times m plus n upon q square. Okay, so let me reciprocal both sides again. So this will give me b square upon ac times m plus n is equal to q square upon pr times m plus n. Okay, so this m plus n will cancel out as both of these terms are in the denominator. Okay, so now let me just cross multiply these terms. Okay, so b square upon q square will be equal to this ac upon PR. Okay, but I can write that as separate terms as it is given in these brackets. Okay, so let me isolate this first. AC upon PR, which can be written as A upon P times C upon R, right? Okay, so now if I cross multiply again, then I get B square upon Q square, and this A upon P, if this goes to the other side, this will become the reciprocal, that is P upon A. And this C upon R, if it goes to the other side, this will again reciprocal itself, and it will become R upon C. And we are left with no term is present, and these are in product form, so nothing but 1. Okay, so now if I go back, B square upon Q square is equal to, if it goes to the other side, this is AC upon PR, right? And I think this was the question. B square upon Q square times P upon A times R upon C. Okay, so yes, this is the final answer solution that was asked in the question. Okay, so the final answer is 1. And for this question, basically I have just used the ratio of roots to be equal. So I took the roots as m alpha times m alpha and n alpha in the first equation, and m beta and n beta in the second equation, and just use the sum of roots and product of roots for this 4 cases. Okay, sum of roots of both equations and product of roots of both equations, and I have just equated mn for this first equation and mn for this other equation. I have equated them, and from the sum of roots I have found the value of alpha, and then I've just substituted that here. Okay, and then it is just slight algebraic manipulation. Okay, it's not so tough, it is relatively easy. Okay, so this is it. Thank you.